My name is EternalBlue. Like she already told you, I'm a security research engineer with Excel's application and threat intelligence team. My presentation is entitled EternalBlues with EternalBlue. I guess I have an explanation for that since it's a bit cryptic. EternalBlue is an exploit for Windows operating systems which appeared sometime in spring. It's most known for the WannaCry ransomware infection. You've probably heard about WannaCry. And what we've seen is that some other malware authors have started using it, and that it's been seeing some traction, so we can see some increase in the number of attacks using this exploit in the wild. So, just a quick recap on me. So I'm a threat intelligence engineer, that's the umbrella thing, that's the umbrella term. I spend my time researching attacks, malware, bots, and the like. A very quick outline of the presentation. First, I'm going to talk to you about the exploit, how it appeared in the world, what it does. I will show you how we detect online scanning and exploitation. Then I'll run you through some of the active threats that we are actively seeing in the wild. And then some stats, because the presentation would be complete without stats. And of course, lunch in the end. I forgot to add lunch. So if you were somewhere far away this April and May and have not heard about EternalBlue and WannaCry, hopefully that's not the case, but I'll walk you through some stuff anyways. So at some point in history, a mysterious hacker group known as the Shadow Brokers appeared, and they said they had obtained a complete toolkit and exploits belonging to an APT group known as Equation. These guys tried auctioning their stash, failed to round up all of the money that they wanted. So at some point they dumped some of the stash out on the internet, made this way all the way to GitHub, as you can see, and people found a complete exploitation framework similar to Metasploit in some respects that allows you to exploit a system, to do some proxying, so you can hide your original IP, do post-exploitation using some backdoor modules. And of course, an exploitation framework comes along with a bunch of exploits. Some of them were 0 days, and the ones that got most interest was the Eternal something family of exploits. You can see Eternal Champion and the subject of our talk, EternalBlue. So EternalBlue targets Windows operating systems. It's a buffer overflow for SMB v1. All systems from XP up to Windows 10 were vulnerable to it when it appeared. Somewhat mitigated by the fact that most recent versions of Windows do not enable SMB v1 by default. FuzzBunch, that's the name of the exploitation toolkit of the framework, did not support other systems other than XP up to Windows 7 and 2008 R2, but people were quick to adapt to the exploit itself. So nowadays you can find the POCs also exploiting Windows 10 using this vulnerability. The backdoor module that we're most interested in is called Double Pulsar. So it's a shady backdoor that gets deployed once EternalBlue completes successful in the system. It communicates via cover channel, so it communicates using the SMB protocol. The traffic itself is XOR encrypted and somewhat stegoed inside certain fields, like timestamp fields and other fields in SMB which might bypass an IDS detection device. So after WannaCry died, you probably know that it died because of a kill switch domain being hard-coded inside and the domain being registered by someone. We thought there might be other actors who might try to use this exploit against the world because we already have the tools available, they're easy to modify, WannaCry proved that they're easy to be used even if not using the exploitation framework itself. So we reverse engineered the stuff that FuzzBunch did, took all the traffic. You can see a buffer overflow, so a lot of traffic being generated there. And we modified our existing SMB honeypot so that it first advertised vulnerability. It would accept all of the necessary exploit traffic and respond in a good manner. In the end, trying to emulate a double pulsar payload. So the honeypot says it's infected with double pulsar, and you are now able to send your post-exploitation tools towards it. So to identify the threats, we have this double pulsar mutation. Double pulsar receives from the attacker a piece of shellcode that it uses to inject the DLL file. It also receives the DLL file in there. The DLL files themselves are pretty simple and not much interest, so to speak. So WannaCry had all of the necessary ransomware logic inside the DLL file. It contained embedded binaries that it would drop and execute. It contained everything it needed. The stuff we're seeing nowadays does not do the same thing. Instead, the DLL file simply downloads malware from a remote URL. So we did some highly advanced string analysis that you can see over there, and found malware download URLs, started downloading stuff, and then profiting from the added threat intelligence that we could gather. So the first tool that we found is called GhostRat. It was in the news quite some time ago. It's an older threat. It's a nice and shady backdoor, a remote access Trojan that offers an attacker complete control of your system in real time. It can capture camera input, it can capture your microphone, it can transfer files, it can do whatever. AV products nowadays have very good detection for it, since it was used in espionage campaigns a long time ago. So, for example, we would find a new sample of GhostRat in the morning. It would have a compilation timestamp, like 1 or 2 hours before we found it, upload it to VirusTotal, and even though it had never been seen, we had 40 or 50 products detecting it from the first point on. Network security devices, on the other hand, they also have good traffic rules. You can see that the network traffic it does has a signature ghost inside it. Normally they would be able to use that to detect. However, some people deploy custom modified versions of GhostRat which do not have the same labels. So we have found different other labels being used in the traffic. If the IDS device relies heavily on that for detection, it's not probably going to have a problem if it has not seen that custom sample before. Second threat we found, again something that is older, not necessarily the latest threats. It's called the Neato DDoS bot. Sometime in 2012, Microsoft tried to take it down. They actually sued a DDNS provider which was being used in order to identify CNC servers by the malware. You can still find those DDNS provider strings inside the binary file. What it does once it gets on a system, it does some simple fingerprinting. So it's going to send towards its CNC server, Windows operating system version, some CPU info, memory info and stuff like that. I assume it's some sort of sandbox detection method that they implemented. Then, from time to time, it's going to receive a target IP and starts flooding it with network traffic. So I've only seen it attacking port 80, web servers. It sends large buffers of data, megabytes upon megabytes, but not legitimate HTTP traffic, just all A's, all C's, and stuff like that. So something completely useless and detectable. Now back to our days of threats. Some people might not call this a threat, but if it's being installed by an exploit, I would say it's a threat. We have cryptocurrency miners, and we're seeing a lot of them coming by this means. The currency of choice seems to be Monero, XMR, so that kind of makes sense since we're infecting Windows boxes, not us, they are. And Windows boxes will generally have Intel or AMD CPUs, and the proof of work hashing algorithm in Monero, Kryptonite, works best on these systems with very large L3 caches. So this is one sample wallet we found. This guy managed to mine about $3,000 worth of crypto coin in 1.5 months. Not the best of paydays, but a good payday nonetheless, especially if he's holding on to the money, waiting for the currency to increase. He's probably going to make a lot of money at some point. He continuously counts back every 2 or 3 days and transfers somewhere around $70 worth of coin back to another wallet. Untrackable, of course. Very funny thing about currency miners, they seem to be very territorial. So even though they like using other people's boxes, they don't like other people being on the same boxes as they are. So on the left side, you can see an example of a script that it uses for the first steps of its deployment. I don't know if you can see it very well. It does the standard backdoor stuff, create a hidden admin account, start the malware itself, etc., etc. And then it starts actively blocking SMB ports. I find that highly interesting, right, for myself, because that means this is an attacker who didn't just get on the box via whatever means possible. He knows he is exploiting a Windows box which is vulnerable to SMB exploits. And knowing that, he decides to block all traffic via firewall, open ports for backwards connection to his own CNC servers, and that's about it. Basically blocking the box from other miners. On the right side, this guy starts doing task kills. He kills some tasks. The names themselves aren't very interesting, so not AD product names or scanner services or whatever. But those are names that we did find in other samples of miners. So it appears that they do not like other miners. When they get out of the box, they're just going to kill them, block all access, and this box is now mine. And of course, no discussion about EternalBlue would be complete without the WannaCry. If you think WannaCry does not exist anymore, think again. We could catch samples continuously in our honeypot. So we have standard WannaCry, the one with the kill switch domain. It's very easy to identify. You can do just basic string analysis on the DLL file. You will find it always has an entry point called play game. You will always find the kill switch domain inside it, and you will always find the SMB traffic, since all the SMB traffic it does for exploitation is contained in the executable directory. We also found a clone that people had developed no kill switch WannaCry. This one was modified on the binary level, so even if the kill switch domain exists or not, it's going to try and execute the malware on the box. Luckily for us, they made the malformed binary, so it does not run correctly. You can see a screenshot. This is from a sandbox execution, where the Windows loader refuses to load the executable because it's malformed. The reason I'm mentioning this sample is because what I found interesting, I identified a Bitcoin wallet inside it. Instead of Bitcoin wallets, I found some URLs for paymentnew.ok.ru. So ok.ru is a social network in Russia. They allow people to trade real life coins for some sort of intra-platform currency that people can use to buy gifts for their friends, do different types of payments and such. And I assume, I couldn't test this in any way, so that's I didn't want to access those URLs directly and do whatever with them, that they actually trying to find a new means of money laundering instead of simply using Bitcoin. That's about it for the active threats front. So on to stats and closer to lunch. This is the number of attacks we've seen, and I think this graph kind of justifies what I was talking about when I said this is gaining some traction. The number of attacks has increased. The data for October, even though it seems less than September, is partial, so it only accounts for the first 3 weeks. And with 3 weeks, you can see that it's almost up to the level of September, so there's more and more interest in exploiting this. Now, I said at some point, maybe they're not actually, there are not more actors, or there's more interest, just some people doing faster for loops, trying to find more ghosts. So also looked at the IP count. We tracked the IP addresses which have tried to attack our honeypots. And the IP count has been increasing as well. And even if they're proxies, since I guess most people will say, hey, but those are proxy machines, they're not attacking you directly. Even if they're proxies assume there's some sort of added cost, right? So you either rent the proxy for someone, in which case you pay money. You either infect some different machines, in which case you have some administrative overhead, so to speak. So the number of IPs increasing, I would say, is a sign that people are actually finding something to gain by using this exploit. So, geographical distribution of targets. What is the worst place in the world to hook up your old SMBV1 vulnerable Windows machine? As always, when it comes to targets, North America and Europe completely rule. It's a very large difference. I would have expected a difference, but not that large. I actually tried talking about it to some people. Someone suggested that there might be some skewage in the distribution of our honeypots. So if you also wanted to ask me that, we do have skewage in the distribution, but not one that should account for such a large difference in the total number of attacks we see across areas. Then I tried looking into attackers themselves, trying to identify what kind of boxes they're attacking, what kind of machines they're exploiting. So my first idea was look at geolocation and geographical distribution. Again, the United States rules everything. Obviously, whenever we're dealing with attackers, the US is somewhere up and top. Russia, another recurrent candidate. And then a lot of countries from Asia. I could not make a meaning of that. I assume there are a lot of Windows boxes in Asia, since there's a lot of Windows malware which spreads around there with different types. Most likely not up to date, and people are exploiting them. But I will show you some stats on the types of hosts that we are seeing. That have been used since a bit less sure right now. So then instead I would look at the types of hosts, try to identify maybe what kind of exploits they're using to strike the boxes that they're usually using to attack us. My first idea was, hey, SMB vulnerabilities, there's one well-known SMB vulnerability before this package. So configure host infected with configure. And if you have to ask, yes, they still exist and they're still actively striking honeypots and getting caught all around the world. So I could only find one IP that I could certainly pinpoint as being both configure infected, a real Windows machine, not netted and everything. There doesn't seem to be much correlation here. I can give you a good answer for that. I can assume that maybe they're very old boxes and nobody's interested in them anymore, even though they exist in the world right now. I did, however, have a lot of success in identifying that most of the stuff that we see are like small home user devices, residential devices, most likely infected computers, maybe some IoT devices. So the first one on the left is a device which only has port 7547 open. That's the TR069 port, a remote management protocol being used by routers and IoT devices and different types of embedded equipment right now. Next up, it's a router, that was definitely a router, it's a MikroTik router, again something that might be a small business or a residential customer. I don't know if the device itself is the one infected and being used for the attacks. It might simply be a box being netted from behind it, but again, that's theory. The SSL certificate down here is again, router, small device, home user. And up on top, we have two IoT devices. One of them is a D-Link webcam because we've seen that webcams are becoming more and more dangerous by the day, month, and year. The other one is an HTTP server calling itself UC-HTTPD. If you do a quick Google search for that, you will find that it's also an IoT device. So that string is being used by a Chinese IoT device manufacturer, which also manufactures webcams and the like. So now that I've told you about residential customers, I also thought I would try to identify, do we have any sort of infected enterprise systems which are actively attacking us, actively being used to attack us? Not much to see here, so I only found a few machines. The few I could find, I find the connections too flimsy to actually be 100% enterprise. A lot of them seem like failed and forgotten tests. Like a Windows Server machine with RDP enabled and directly connected to the internet. The one below it is a DNS server, so no other open ports, just a DNS server with recursion enabled. In the center, you have a VPN termination device. So that's something that someone could also add to their home router if they want to, but most likely that appears to be like some sort of smaller enterprise system. Probably it's a NAT device as well, so it has an infected host behind it. And the last one, which I could say is enterprise, but again, very flimsy connection to the enterprise. This is another Windows host with RDP enabled. It's running MySQL. You can't connect to MySQL by default. It blocks all IPs except for its chosen ones. I don't know which those are. It doesn't have any sort of other applications running on it. Most likely there was a second box connecting to the MySQL server there and being whitelisted. But the reason I think this is some sort of test gone wrong or some horrible misconfiguration, the SSL certificate is issued, is self-signed and issued by a host with a default Windows box name. So you know when you install a new Windows system, it's going to call it win minus random characters. So this is why I think the enterprise systems are not being used for these types of attacks that much. So that's about it for me. I guess you'd be expecting some sort of conclusion since I talked all over the place. I guess the conclusion would be to never forget that the fact that one exploit or one threat might go out of the news. We might say it's dormant, but it's always there, it's active. So even if WannaCry is no longer functional, please do not connect random PCs in your basement with SMB v1 and vulnerabilities to the internet. That would be it.